Today, I'm going to discuss the addressing modes which are used in 8086. You know, the addressing modes we have already studied in the 8085 also, because whenever we want the processor to do something, to perform something, perform a specific operation on the specific data, operation which is being performed, it is represented by operation code, and the specified data on which it has to perform, it is specified by the operand. So every instruction is consisting of these two parts. So the programmer who is writing a program, it is must for him to specify the required data for an instruction, because without instruction, without the data, instruction cannot work. So this required operand may be placed in the accumulator, it may be in the general purpose register, it may be in the memory location. Anywhere the operand can be defined. So the way by which we are going to specify the operand in an instruction, it is called the addressing modes. So the way we are specifying the operand in the instruction is known as addressing mode. So the definition of the addressing mode is same as in the case of 8085 or in the case of 8086, because it is the way to specify the operand within the given instruction. Because as I told you that what operation is being performed, it is defined by the opcode, but on which it has to perform, it is defined by the operand. So different ways of defining the operands are known as addressing modes. So in case of 8086, we have 13 types of addressing modes which are normally used. I'm going to give you general way of specifying the operands. The first instruction which is used for as a data transfer instruction, it is known as move destination source. Now the destination may be a memory register, it may be the microprocessor register, it may be the and source may be the register itself, it may be the memory location, it may be the accumulator. So that is why the format of using the instruction move in case of 8086 is move destination source. Destination is written first and source is written later. So the first instruction, the first addressing mode is immediate addressing mode. Immediate addressing mode says that whatever data you want to transfer, you have to specify that particular data within the instruction. And that is why if it is a 16-bit data transfer operation, then we will write move CX4373. So what this instruction will do, 4373 will be copied in the CX register, in the C register. Since CX is a 16-bit register, so this 16-bit data 4373 will be copied in the C register pair, CX register, which is of 16-bit. Besides that, in 8086, if we want to work with the 8-bit number, it provides the facility by using an instruction move CL48. Here we want only 8-bit data to be transferred. So we are mentioning only 8-bit register. That is why CL is written. You cannot write CX48. No. If you are writing CX, it means it is a 16-bit register. So you have to define 16-bit data. If you are writing 8-bit register, then you have to define only 8-bit data. Otherwise, since the format will be wrong, then this instruction will provide an error and it will not be executed. So it means the data is to be supplied immediately within the instruction. So that is why it is called the immediate addressing mode. The second one is the register addressing mode, in which we don't know that what data has to be transferred from one place from the source to the destination, but we know the address of that data. If the data is residing in any one of the register and we want to transfer that data to any other register, then in that case the addressing modes which will be used it will be register addressing mode. So example of register addressing modes are move CX AX. So what does it do? It is going to copy the content of AX, which is a 16-bit number, into a CX register. If we want to copy an 8-bit number into the 8-bit register, then we will write move CL AL. Now the operand which is written right hand side, that will be working as a source, and the operand which is written as left hand side, it is known as the destination. So it is going to copy the data from AL to CL, and this instruction is going to copy the data from AX to CX. Similarly, we have direct addressing. These three addressing modes I am discussing just because these three addressing modes are also used in 8085. In case of direct addressing mode, directly the address is provided. Here what we want to say, we have defined the address. We have defined the address of the memory location. Of course, the address of memory location is defined by a 16-bit register, by a 16-bit address. And as we know and discussed in the previous lectures, that the memory is signified by a 20-bit address. And here I am defining only the 16-bit address. So what this actually means, this is the effective address. It means this instruction is going to copy a data from the memory location. Which memory location? The memory location which is having 20-bit address, whose base address will be provided by the data segment, and the effective address will be defined directly within the instruction. Now, it is written within the bracket. So it means 437, whenever any number is defined within the bracket in 8086, it represents the address. Here, whenever we want to represent 4373 as a data, we don't provide the bracket. So the difference between this instruction and this instruction is, here 4373 is a data which is to be copied in CX register. Here 4373 is not a data, since it is written in a bracket. 4373 is an effective address, and this effective address has to be added with the content of segment register, that is the data segment. Since we want to copy the data, so it will be definitely working with the data segment portion of the memory. So whatever is the content of data segment, that is 16-bit address, it is shifted 4-bit left, and then this effective address is added into that, so that it will be able to constitute a 20-bit address, and the content of that 20-bit address will be copied in the CL register. Since it is a CL, so it means we want only 8-bit transfer, so only that memory location content will be transferred to the CL register. Second instruction is move BX 4878, and 4878 is written in a bracket. If this bracket is not present, then 4878 itself is going to copy into the BX. But here it is not so. Here 4878, since it is written in the bracket, it is representing the effective address of the memory, whose base address is given by the data segment. And these data segment content will be shifted 4-bit left, and 4878 will be added into that. And so it is going to generate a 20-bit address. That 20-bit address will be the address of a memory location. And from that memory location, the content of the memory location will be transferred into BL register. And then automatically it is going to increment by 1, so that the content of 4879 effective address will be copied in BH. Similarly, if we want to, we can copy the data from the register pair to the memory. Here the memory, the destination address has been defined within the bracket as 4878. So it means it is going to copy the content of BX, that is BL and BH, into a certain memory location. Which memory location? So 2 memory locations will be required to copy the data from BX, because BX is a 16-bit register containing BL and BH, and these 2 8-bit data has to be copied in 2 successive memory locations. One successive memory location will be represented by 4878, and another memory location will be represented by adding 1 into that address, that is 4879. And how we will be generating the address of the memory? We will consider the base address from the data segment. Whatever is content of data segment register will be, it will be shifted 4-bit left, and then 4878 will be added into that to create 20-bit address, and that 20-bit address will be address of the memory, and that content of memory address will be copied in BL, and then 4879 will be added, means adding 1 to get the successive memory location, and the content of that successive memory location will be copied in BH. So this is the general way of explanation. Now we come to the actual addressing modes of 8086. We have seen already, now we can categorize into 5 parts, and in totality it is having 13 addressing modes. The first category of addressing mode comes into the category of register addressing mode and the immediate. Then we have addressing modes for the memory data. Then we have addressing modes for input output. Then we have relative addressing. Then we have implied addressing. So one by one, we will be discussing the addressing modes. Now, as far as the register addressing mode, a register name will be specified. Now, this can happen that move CLDH. It means we want to copy only 8-bit data into an 8-bit source and 8-bit destination. DH is a 8-bit register. DCL is another 8-bit register. We can copy the data with the help of move instruction. So DH content will be copied in the CL register. Similarly, we can have a 16-bit transfer in which the BX content, which is a 16-bit, it will be copied into the CX register. In case of immediate, we have to supply the data immediately within the instruction. So this is a 8-bit transfer. So 04 is copied in the CL register. Similarly, 0432, 16-bit number is copied in the CX register. So CL will be having 32 and CH will be having 04. Direct addressing, I have already explained, but let me go through that. Direct addressing says that an unsigned 16-bit displacement or 8-bit signed displacement can be specified within the instruction within a bracket. And whenever we are specifying any 8-bit number or a 16-bit number within the bracket, it signifies the address. So actually the address is calculated with this, that memory address or the physical address is equal to base address plus effective address. Base address is defined as is signified as BA, and effective address is signified as EA. So here the effective address, which is defined within the instruction in the form of a direct addressing mode, is 08. So whenever it says 08, it means the effective address is 0008. And so what will happen? We have to take the base address, shift it 4-bit left, or we multiply it by, the number is multiplied by 16 16 decimal number. Both will be working in the same manner, or multiply it by 10 hexadecimal number to shift the 4 times left. Either we multiply the content of the base address by 16 decimal number, or maybe multiply it by 10 hexadecimal number. It automatically means it is going to shift 4 times left. So instead of saying 4 times left, we will be multiplying the content of the base register, base address by 16 decimal, so that it will be shifted 4-bit left. And once it has been done, then only the memory address is generated with the help of modified base address plus the effective address to get the memory address. So what will happen? So whatever memory address is generated over here, the content of that memory will be copied in the DL register. The content of the memory is copied into the DL register. And then next memory location, which is MA plus 1, that is memory address plus 1, will be copied in the DH register. So this is displacement. Now this displacement can be an 8-bit, or this displacement can be a 16-bit. If it is an 8-bit, it is converted into a 16-bit. If it is a 16-bit, it will remain as it is as 16-bit. And later on, this effective address is added with the modified base address by shifting it 4-bit left. And how it can be done? By multiplying the base address content by 16 decimal 16. The third category is register indirect. Now, you see, in addressing modes of memory data, we have direct addressing, we have register indirect addressing, we have based in addressing, we have indexed addressing, we have based indexed addressing, we have relative based indexed, and we have a string. So we have in this addressing mode, we have this much category of the addressing modes, out of which we have discussed direct. Now coming to the register indirect addressing. How it works? The name of the register which holds the effective address will be specified in the instruction. In case of direct addressing, the direct address is defined directly. But in case of indirect, the address is not defined, but the place at which the address has been defined is written as an operand. So what does it mean? Now the effective address can be defined by BX, DI, or SI. Any one of these registers can be used to define the register indirect addressing. So if it is move DX, BX, now BX is written within the bracket. It means BX is considered to contain not the data, but the address. So effective address is placed in the BX. So whatever is the content of BX, it is considered as a effective address. And then base address, which is a data segment content, it is shifted 4 times left by multiplying it by 16 decimal 16. And then memory address is calculated with the help of modified base address plus effective address. And the content of this memory address is copied in the DL register, and the next memory location content is copied in the DH register. Similarly, we have another example, move AX DI. Now here DI represents the effective address. So DI contains some effective address. So whatever is the content of destination index register, it will be considered as the effective address. And then we modify the base address, which is available in the data segment. Since we are working on the data, so that is why we are every time I'm saying data segment. It is shifted 4-bit left by multiplying decimal 16, and then modified base address is added with the effective address, which is the content of the destination index register. And then we are able to generate the memory address. And the content of this memory address will be copied in AL register, and the content of next memory location will be copied in the AH register. Now, moving ahead. The next addressing mode is the based addressing. In based addressing, BX register or base pointer are used to hold a base value for the effective address. Whatever is the effective address, in case of base addressing, we will be using only these two registers, base pointer or the BX register. And along with that, a signed 8-bit or 16-bit displacement is specified in the instruction. And the example of based addressing is move AX BX plus 08. So what does it actually means? This actually means that BX contains an address, 16-bit address. It has to be modified. It has to be displaced by 08. So effective address is first calculated with the content of BX plus 0008 to get the effective address. And once we get the effective address, we take the base address, modify it by shifting 4-bit left by multiplying decimal 16. And so we are able to generate a memory address that is equal to base address and this effective address, which is the addition of 0008 and the content of BX register. So the content of memory address, which is generated here, will be copied in the AL register, and the content of MA plus 1 will be copied in the AH register. Now, if BX is used, if here we are using BX, then data segment register content will be considered. But if base pointer is used here, in that case, the base address will be provided by the stack segment. So if I am using bx, it means the base address will be given by the data segment. But instead of that, if we are using bp, it means the data segment will be replaced by the content of stack segment. So that is another example has been shown in which move dx bp plus 09. What does it will do? BP will have its own 16-bit number. It is added with 0009, and then base address will be considered not from the data segment but from the stack segment, because it is defined previously that BX is meant for data segment and BP is meant for the stack segment. And once we get the value of effective address as well as base address by shifting it 4 times left, we add these two numbers to get the physical address or the memory address. And then the content of this memory address will be copied in the DL register, and the content of next memory location will be copied in the DH register. Then we have indexed addressing. In based addressing, we will be using BX or BP. In case of indexed addressing, we will be using source index register or destination index register to hold the index value for the effective address. Along with that, signed 8-bit or 16-bit displacement is specified within the instruction. So the example of indexed addressing is move CX SI plus A2, where A2 represents, now in this case, A2 represents FFA2, not 00A2, but it is a FFA2. And this FFA2 is added with source index content to get the effective address. And once we are getting the effective address, we shift the base address, which is given by the data segment, shifted 4-bit left, and then it is being added. So memory address is added to get the memory address. It will be equal to base address plus the effective address, and whatever is the content of memory address, it is copied in CL register. Sorry, it is CL register. And CH. So now there is one difference in between based addressing and indexed addressing. In case of based addressing, if displacement is given, 8-bit displacement is given, it is added with 00. But if it is a indexed addressing, the 8-bit address which is given, it is added with FF. So based and indexed addressing seems to be similar. They are same type of thing. The difference is, in case of base addressing, we will be using BX or BP. In case of index addressing, we will be using SI and DI. So here we will be using source index register content to add with the FFA2 to get the effective address. So it seems to be similar, but in base addressing, the base value is the reference and the displacement is the modifier. This base value means data segment is the reference, or this reference has been displaced by 0008. But in case of indexed addressing, displacement is the reference. This is the reference, and source index is the modifier. So that is why here FF is added, and in previous case it is 00 is added. So in case of indexed addressing, source index will be considered as a effective address, and so data segment will be taken. Now, so I think based addressing and index addressing seems to be clear. In case of base addressing, the base value is the reference and the displacement is the modifier, whereas in index addressing, the displacement is the reference and the index value is the modifier. Now we have another category of addressing mode that is called based indexed addressing. It means base pointers will be used as well as index pointer will be used to create a effective address. So this effective address we will be getting For example, move dx bx plus si. It means bx will contain certain 16-bit number, si contains 16-bit number. So the content of bx and si is added together to get the effective address. And once we get the effective address, we shift the base address by shifting the content of data segment register 4-bit left, and then it is added with the effective address to get the memory address. So whatever is the content of memory of this memory generated here will be copied in DL register, and MA plus 1 means the next memory location address, next memory location content will be copied in DH register. The next one is the relative based indexed addressing, in which based addressing in case of base addressing we will be using bx or bp. In case of index addressing we are using si or di. In case of based index we will be using both. Now relative based index addressing, we are adding again the some displacement value. So it means before you calculate the memory address, you have to calculate first the effective address, because the effective address is the combination of content of bx plus the content of si, that is source index, plus the 8-bit or the 16-bit displacement which is defined within the instruction. And then the summation of all these three will be giving you the effective address, and base address will be shifted 4-bit left by the content of, by shifting 4-bit the content of data segment, and then memory address will be created, generated, and the content of that memory address is copied in DL register, and the content of next memory location is copied in DH register. And the last one is the string addressing. We have gone through direct, register indirect, based, indexed, based index, relative based index, and the last one is the string. So let us discuss about the string addressing. In case of string addressing, the effective address of the source data is stored in source index register, and the effective address of the destination data is stored in the destination index register. And the segment register, which is used for calculating the base address for the source data, is data segment, and for the destination data it is the extra segment. So effective address will be in source index and base address will be in data segment. Destination के case में destination data will be stored in DI register, will be effective address will be in the destination index register, and the base address will be available in the extra segment. So how we will go? Suppose this is the instruction which is written for the string manipulation. Move s byte. So what it will do? It will copy a byte from one place to another place. Now we don't know what is the address. We have to calculate the address. First we will calculating the address of the source. We have to move the data from one place to another place. So we must know what is the address of the source. We must know what is the address of the destination. So both addresses must be calculated. So how we will calculate the address of the source? Effective address will be given by SI register. Base address will be given by the destination, by the data segment, and memory address will be created by adding the base address and the effective address to get the source address. Destination address, destination for creating memory destination address. What is the effective address? Effective address is given by the destination index register, and the base address is given by the extra segment register. And then we will be calculating the destination memory address, that is BAE plus EAP. So by this MA is the source address and MAE is the destination address. And this source address content will be copied in the destination address. If DF is 1, if the direction flag is 1, then SI minus 1 will be SI and DI minus 1 will be DI, means the highest, from the highest to the lowest. But if direction flag is 0, then SI will be SI plus 1 from increasing order. This is the decreasing order. From the back side, we are copying the data. Here in the case of direction flag is 0, so we are copying from the front side, means from top to bottom or from bottom to top. So if direction flag is 1, it is from bottom to top. But if direction flag is 0, it is from top to bottom. So first of all, we will take the SI, and then SI will be incremented by 1. But in case of DF is 1, then SI is decremented by 1. So this is the case of the string addressing.